stuck in traffic? I got stuck on Ritchie when I headed out.
Traffic wasn't bad because there was no electricity in the there was no traffic light.
Oh, yeah. Yeah, that was crazy. Trying to get to the light. It was crazy. Even in college, I tried to get off Ritchie. There's that place in the light zone. Trying to make it. Josephine. What's it? Well, let's decide it tomorrow. We can still do it Monday, but I'll feel it out. Does that sound good? Yeah, like, what we'll be able to do is, tomorrow we'll probably do everything but one section when we have time to finish that one section tomorrow, and then review. But I'll still feel it out, you know?
I hope it.
You fill it out, if you want it, if you need an extra day, we can do that.
So I test
We'll decide it tomorrow. We'll decide it tomorrow. Let's.
The tenth?
Yeah.
Let's work on it.
No.
We're kidding.
Yes, I was looking at the schedule yesterday.
So you better not
We
do
can
it
still
tomorrow.
have it Monday, we'll finish stuff, and we have time to even review tomorrow, but, and we'll feel it out. We're like, nah, let's have Tuesday, we could.
Are you good, are you good?
No problem with that.
So Tuesday,
I'll ask, we'll let, like, we'll do like class vote. Democracy, will that work?
yeah.
Does that
I
work?
don't think anyone's gonna say tomorrow.
No, not tomorrow.
Okay.
We're joking about
Oh,
that.
okay.
Never tomorrow.
Okay.
That's out of the question. But we saw it Monday, Tuesday, we'll feel it out. So Josephine, we can do it Tuesday, we can still do it Monday, you would see that like we finish. It's, the last section's called Newton's method, we do it tomorrow. And Newton's method doesn't take 2 hours, it's fun too, and then we could have, you know, at least an hour review time, so. But if you're like, oh, I want an extra day to review, we can definitely do that.
Professor,
Yeah.
will it be possible for you to just a review on 4.3, number 7? I'm gonna,
Let's do it.
number 7 and number 32, you gave it. I just want to make sure that I have the right answer.
Yeah. Was it an even one?
32 was even, yeah. And number 7 is,
Uh,
number 7 is, I'm getting a kind of wrong answer.
I'm gonna check that out.
That's POI.
Can you also do 35 and 39 and 4.1?
You bet. I'll watch in about 2 minutes. I'm gonna go, what problem did they have? 539. 3539. I don't remember. 3539. Okay. 39 is next to the 4th, 5th times that.
That, yeah.
Which,
I makes it a pain.
Are we even gonna do something like that, or should I just ask for the 23?
We can still do it. It's fun. Probably. It's fun to do. Makes you more powerful. You know, in terms of every time you learn a new little trick of factoring or something, it just makes you, next time you see that scenario, you're like, oh, now I'm ready for it. In case it came up in Calc 2. Do you gotta take Calc 2? Oh, okay. So now, I gotta check on, I'm hoping the answer's in the back of this. That way you and I can just check. Now, sometimes the instructor edition, I'll put the evens in the back. I'm gonna get mad if it isn't. Come on, man. Oh, boring. All right, I'm looking in the back.
for number 32?
Me and you're gonna have to work it out. I was hoping they'd put the even answer in the back. This is an instructor's edition. They don't have it.
Oh,
Okay, so it was number 32 and 4.3?
yeah, for number 7. Number 7. Number 7, I got the part A.
And it was in 4.3, right?
Yeah, I got part A. That is, then part B is where I'm having the problem. And part B because,
State the x coordinates of the inflection points. Is that, am I on the right one?
yeah, POI, yes.
I love it. let me do that. Number 7 has got a curve. All right. This is on page 298. Okay. And this is the curve, is the graph of what? Are we gonna do A, and B, and C?
Yeah, I got the A, but I was having problem with the B.
I'm gonna
and
go
C.
right to B.
Okay.
And when this curve is F prime. Alright? So even when I write it, I'm gonna put F prime on there. There we go. That's a 2. I got the 4. Maxed out at 6. Alright. Nice and smooth. No sharp corners. That's 7 effective here. Okay. Let me smooth that out, because when this is no sharp turns, we know that in derivatives, there's no corners allowed, right, for differentiability. So it's maxing out there, it's maxing out here. This is F prime.
No, I mean, in A, I took this as F, then I drew F prime. On B, I think I have to draw this, the F prime, right?
Yeah. So this one, this is what they're saying for letter B. They're saying this is F prime, this is what they're saying for
Oh,
letter B.
this is the F prime.
Yep, and then they're going like this. State, and when we did a couple problems like this, so you'll be able to get this. State the points of inflection of the function f. But this is F prime. So we had to look at something with our eyes. Do you remember the hills?
Uh-huh.
Do you remember it was the hills? So let's find, everyone, this is F prime, we're trying to find
So
points of inflection of F.
2, 4, and 6, right?
2, 4, and 6 would be the points of inflection of F. Bingo. Does everyone see this? This is if you got an F prime graph. Ba-boom, 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 because concavity would change, meaning it's F double prime. You see it went up and then down. So really, if you'd like, you want to keep it simple, if you're trying to find points of inflection of F on an F prime graph, don't you look for the little humps, the little hills? That's exactly it. So the answer to this, they only want you to state the x values. State the x values of the points of inflection of F, and we just say at x equal to 2, 4, 6.
Oh, so that on C that means, so that will be F double prime, so that will be 1 and 7, the PY.
Oh man, are you good? I should do that with that one. Let's do letter C. Are you ready? That was letter B. We did that before. I went great job at that. I haven't done this with you yet though. So I want to see what you think. Now, before we do it, we got to know the definition. What's the definition of a point of inflection?
Or double.
And I want to make sure, did everyone get my summary sheet? Sometimes it's nice to have everything on one sheet that kind of, 4.1 and 4.3 was the busy sections. And there was a lot in there, right? And it just kind of, you go through and you go, all right, what's a point of inflection? I have to define it. It's where concavity changes, right?
Mm-hmm.
On F. Concavity changes on F. Something else, something goes on with the second derivative for a point of
It
inflection.
is 0.
The point of inflection is either 0,
Or
oh, excuse me, the second derivative of the function will be equal to 0,
Or D.
or it does not exist. Okay, so, I haven't done this yet, but here's the question. Boom. This curve is F double prime, all right? And here's the question. State the x values of the point of inflections of F.
So 1.
Now. We're gonna go back to the definition, we're gonna get this. We go, oh, we haven't done this yet. I haven't given you an F double prime graph yet, right? But we know the definition is concavity changes, okay, big what to do. But it's, the key is, what's the second derivative gonna be equal to?
0.
If this is a second derivative graph, and the definition of point of inflection, we say the second derivative must equal 0, and concavity changes, that means f double prime must change is f double prime changes at the point. Everyone get your eyes right on that x-axis. Because that's where f double prime would equal 0. What's that answer right there? I'm sorry I didn't label it. What was that
One.
number? There was a 1, this was 1.
Then 4,
That's one of them. Then where else? 4. And where else?
7.
7. Now watch this. Someone's gonna help me out. That's the definition. This and this. Why am I saying my answer is only 1 and 7? Why didn't I include 4? Look carefully at this definition. Second derivative must be equal to 0 and second derivative must change.
Change it.
It's not changing.
It's not changing here, is it?
It stays in one.
It stays positive. It went positive, 0, positive, right? That's not a point of inflection. It's based off that definition. Does someone say that? So I can only say this and that. Cool. Am I getting that? Excellent. I used to put that on the final art. I'd stop doing it. Is that a good one though? That one problem, I used to put that, I was like, oh, I like that. Part C, I put it on the final, and I'm like, no, I got kind of tired of it.
Would you put it on?
Do you like it?
Would you put it on the final for us?
Do you like it?
No.
See, he doesn't like it. I do the F prime stuff. I like to hit the F prime grasp, but I stopped doing it. You know why? Everyone would tell me 1, 4, and 6. I got tired of it. They go 1, 4, and 6, because their mind is thinking what? They're thinking this, but then they sometimes they forget about what? Oh, the second derivative has to what? Change there also, and so that's why we can't include 4. It's a great one, excellent, I like that problem. All right, we got a couple others, everyone needs to come from 4-1. So, all right, I love that one, here's a 4-1 problem. We'll see if we love it or not. 33, right? All right. I saw it had a fraction, it looks like quotient rule, huh?
35.
Oh, 35 and 37?
No, 35 and 39.
35 and 39. And when I saw this thing had a fraction, it looks like we're gonna do quotient rule. It's got oh, we go on to page? Page 281. Alright. Looks fun though. Oh, they didn't write f of x, they decided to write g of y, blah, blah, blah. Everyone okay if I make it g of x?
No.
Yeah. G of y, you can deal with y, I know you can, I'll make it g of x. G of x equals x minus 1 over x squared minus x plus 1. The directions, you don't have to sketch it. You don't have to find max or mins. You gotta find all the critical points. Or your author says critical numbers. They're called critical numbers, critical points, critical values. What's the definition of a critical value? Something's equal to 0. Anyone?
The first derivative.
I'll put CP for critical point. What's the definition of a CP? F prime equals 0, or I'll put in parentheses, or what? Or first derivative what? Doesn't exist. Anything else? That's it. Simple definition. A critical point of a function is a value where the first derivative of the function equals 0 or does not exist. Now we might get this or does not exist because I see we've got a quotient rule and there's some values where it might pop up in the denominator. We'll see. But if there's asymptotes here, we can't include it. All right, so we're basically taking this first derivative. Everyone ready for low D high?
Mm-hmm.
We see it. All right, you're high, you're low. All right. Your F. Oh, see, they got G. I'll use that now. Low, D high, minus high, D low, all over.
Low, low.
Low, low. Okay, low is. What's D high?
1.
Minus high. What's D low?
2x minus 1.
All over? Low, low. Remember with low, low, you never, ever, ever, ever expand it. You just leave it like that. You never expand. You should, no. Alright. And I'm gonna set this equal to 0 to see where it equals 0. But it looks like I gotta FOIL this, huh? Everyone, can you FOIL that thing? But after you FOIL it, Kelly, then I'm gonna distribute that minus. Alright, so let me see. Times a 1, that's easy. But here we go, minus. FOIL that, I get 2x squared minus x minus 2x, that'd be minus 3x plus 1. Notice, Cal, I didn't distribute the minus yet. That's the big error. Happens all the time. Students actually distribute too early and they mess up the algebra. We're gonna wait. Oh, and this is over low though. Now I'm gonna distribute that. Let's see what we get. What's x squared minus 2x squared?
Negative x squared.
A minus here makes it
Plus.
plus 3x.
Mm-hmm.
Yeah.
Plus 3x and a negative x would make that.
Plus 2x.
And everyone just be careful. I gotta distribute that minus. I'd get a minus 1 here.
0.
That's a plus 1. Good, they're gone. The 1 and negative 1 are gone. And what's this denominator? And we're trying to figure out where this is equal to 0 or does not exist. Now you might say for the does not exist, I should set the denominator equal to 0, right?
Mm-hmm.
True? But everyone, we're not going to include that. You go, why? Because that was in the original expression here. And that would be where the values for g would be undefined. There'd be like an asymptote there. Does that make sense? So it wouldn't be a point on a curve. A critical point must be a point that's actually on the what? Curve. A critical point can't be an asymptote. So we get to ignore that